Hi, my name is Kevin Scharpf. I'm with the PTR group, and this is the last Cathedral, Democratizing Flight Software. Also,
could you speak louder, please?
Okay.
Thank you.
Hi, I'm Kevin Scharpf with the PTR group. This is the last Cathedral, Democratizing Flight Software. Note on the title, that is sort of a reference to Eric Scott Raymond's famous essay from the 90s, The Cathedral and the Bizarre, describing the differences between a couple of different styles of development. So, who are we, the PTR group? Well, we're an embedded systems consulting firm based out of Virginia and Maryland. We have been involved in multiple space missions, including TACSAT-2, which is the first Linux in space that I'm aware of from back in 2006. But we've also been involved with multiple projects, IBEX, GLAST, Orbcom, Orbital Cygnus, DARPA F6. We're currently actively involved in some robotic space projects at the Naval Research Laboratory and NASA Goddard, including the DARPA Phoenix program. And we are also a training provider for specializing in embedded Linux, providing a variety of products there. Linux networking, multi-core, Linux KVM, and Android. I am actively supporting Orbcom on their OG2 development, where I'm responsible for the network software, and I am also responsible for the maintenance of the existing satellites that are on orbit. So the first part of this is the viability question. And so what makes is Linux a viable platform? So certainly it has a huge number of platforms to support. It provides hard real-time guarantees with the addition of the preempt RT patch set. Hopefully, I think the goal is to include the entirety of the preempt RT patch set into the mainline in 2014. Hopefully that does happen. There's the vast majority of the patches have actually been included into the mainline at this point. But I think the real definition that we tend to use in the space industry for what is viability is, has it flown before? And the answer there is yes. SpaceX has indicated they're using it everywhere, pretty much, in the Linux World Conference earlier this year. So the more difficult question, though, is there any reason to bother with this? And so to talk about that, I just wanted to go through the general characteristics we use that people frequently use to describe Linux. And because it is free as in beer, and the answer is no. This is irrelevant. The cost of the operating system is irrelevant to the overall mission cost. You heard yesterday that the cost of software as a whole is irrelevant to the cost of the MSL, and well then. This is doubly irrelevant because the cost of the operating system is going to be irrelevant to the cost of software. Free as in speech, no, this is relevant to individuals, but not to the organization at large. Because it is open source, and I realize this is somewhat covered by the previous item as the speech, but I thought it would be useful to talk about it directly. This definitely is useful, and I did categorize it as yes and no, and the reason I caveated that is because I think there was this historical idea that people would just take their kernel and apply changes to it as they saw fit, and I don't really think that's a viable usage anymore. I think you're far more likely to want to take known patches possibly from future distributions or things like that, and then roll those in. So that's a valid case, and specifically preempt RT is certainly something that you want to do there. Also, what is certainly valuable, at least to me historically, is just the ability to look into the behavior of the operating system when I do run into a difficult problem. Still unlikely that the problem is actually with the operating system, but sometimes it is not clear to you via the API that what exactly has been happening. So being able to look through and read into that is certainly something that I have found valuable. So well, going on, does it have higher quality or more features? And we know that these are diametrically opposed qualities. More features, certainly. Obviously, you can get to perfect quality by dropping all your features. And that. So, I mean, I thought an easy way to kind of sum up the number of features provided is just to grab from the Linux README the number of supported processors, which in a sense is a feature set. And it's certainly quite a wide variety of processors that are supported, and there's no point in my reading through that. So higher quality. Well, okay, so Coverity does their annual scan of open source products, and for 2013 they measured a defect density in Linux of 0.59 per 1,000 source lines of code, measured over the 7.4 million source lines of code in the entire code base. And so what does that number mean? Well, so the industry standard is sort of one per 1,000 source lines of code is good. And, but I think the more relevant number is that Coverity reports their initial quality metric when a customer takes their product and runs it on a scan, and runs their initial scan prior to actually employing any patches. That runs to about 1.5 defects. So it's certainly better than average in that regard. It's certainly good, I guess, in some extent. But you can also certainly provide something or get access to something that is even higher quality. For example, if you took I know like Integrity has a formally verified microkernel. Well, that's essentially defect-free at the microkernel anyway. And so that would actually exceed this. So is there a case to be made there? Well, I think the way I look at it is, what defects am I paying to remove at that point? Because at least in my experience, the defects that I tend to run into are actually in what I've written. And so I'm not really sure that the cost benefit is there, at least for the common use case that I'm used to. And certainly I've only been involved in unmanned missions, so that manned missions creates a whole different level of wanting to, I guess, sanity checking that you want. So is there anything else? And this actually gets to where the focus of what I want to talk about is the philosophy of Linux and the community of Linux is where I think the actual value comes in. So everything has to flow back into cost. If there is no case to be made in cost, then there's nothing that's going to be changed there, or there's no reason to. So we know that all of the government budgets are going to be basically really tight, and they're not going to relax those anytime soon. So what is the impact of software on those budgets? Well, software costs are almost entirely labor. So the entire tool set that you provide there is pretty much irrelevant, as I mentioned before. Another thing that software gives us, where we start to get a potentially big advantage, is the late stage flexibility. So during environmental tests late in the program, if something fails, you want it to be software really, versus hardware. If you do have a hardware, if your hardware starts coming in slightly out of specification or maybe performance deficient but still usable, then they're inevitably going to be trying to see if there's a way to push the requirements onto software in order to try to meet that. And I know that's usually a joke that, oh, we make up for hardware and software and make up for software and hardware, but I think there's definitely some truth to it that if something goes wrong in, say, the thermal vac or something like that, you want it to be in software if it had to be anywhere, and except for GSE, which is probably not. So what drives our software labor costs? Well, So what I wanted to look at was where are the developers, and I guess my theory is that the developers are where the jobs are, and I think the jobs are also going to be sort of where the developers are in a nice little circle. So I pulled up job trends from Indeed.com for embedded Linux and VxWorks. So what you're seeing on the y-axis there is the percentage job growth over time. So, and what you're seeing is that there's a steady increase in the number of jobs available on Linux, and basically the job growth on VxWorks has been negative for the past 7 years. And I should say that I'm not really trying to fool you. You probably can't see the 0 very well, but it is pretty much lined up on both those charts, and the 25% is pretty much lined up. So the scaling does match pretty well. I also think it's undeniable that you'll see this downward trend on embedded Linux starting around January 2011. You see that steep decline, and I can't actually fully explain that, but I will note that I have actually looked at the number of embedded Android jobs, which basically takes off like a rocket starting around January 2010 or something like that. So I have a feeling that probably makes up for some of that. Obviously, that's something I can't prove, but that is probably at least a factor. So what else is driving our software labor? So what we would like is for our developers to be 100% efficient. And so what I have here is just a simple model of, I guess, my workflow that I tend to follow. And so there's a change that comes in, and yeah, I'm going to compile it, and I'm going to run it through a static analyzer. I'm going to run it through software unit tests and software integrated tests. And probably at the same time as that, I'm going to be running it through a dynamic analyzer to verify that everything's clean there. And then once all that's through, then we can go through review and actually putting it on hardware. Obviously, that's a simplistic sort of waterfall view, because at any stage you can need to fall back to the beginning. But what I really wanted to capture is that every stage you're actually waiting for something, and you're waiting for something to come back to you, a result that you can use, and then figure out what action or what change you need to make now. So the easy example there is the compile stage. I know I personally have worked on programs where the full compilation of the entire system could only be run overnight, because it would take 10 hours or something like that. And how does that affect you as a developer? It ends up encouraging very bad practices. If you can imagine what I ended up doing, and I'm sure many other people's doing, is well, I can't stop developing after those first couple of lines, or I would like to compile and make sure that everything was clean. So instead, you write a couple of lines, stare at it carefully, and move on and keep on building on top of your feature set. And then really you want to try and get everything in for that massive nightly build, which inevitably fails at the same first 2 lines because you find that your mental compiler isn't so good. But even if your delay time is much shorter, then even after a few seconds, you're context switching out from whatever you were doing into something else, possibly another feature, possibly to check email. Then you're going to go back and check it, and then you need to rebuild your entire stack of whatever task you were doing to try to figure out what the error was. And the same thing really applies for all these stages. You're waiting on something to happen to get a result, and sometimes you're waiting on that resource to be available to get your result. So let's say your static analysis is a product that is a sort of company or organization-wide product, then you may not have access to it for that day or that week or whatever, depending on what the schedule is of that. So what does the developer do then? Does he skip ahead to a different stage? Well, it would be kind of unfortunate if he goes forward and then finds that his answer would have been pointed out to him immediately if he had access to it. So what I wanted to talk about was how do we reduce these feedback cycles? And I think the goal is to achieve the highest quality possible prior to ever reaching a blocking point in development. So what I do in my workflow is, so everything actually ends up building completely on my laptop, and I would say everything to within maybe 100 lines of code out of 200,000 or so. And the result is that I'm not stuck on anybody else's compile stage. I get that feedback immediately. The static analysis, I fully support the use of whatever best tool you have access to as a program, but for an individual, I'm going to take whatever I have available, which in my case, that ends up being some combination of Splint and CPP check and the C-Lang static analyzer, all of which are nice. And what I wanted to, another nice thing about that, once I've started push my development onto my own system in that fashion, is that all of a sudden my compiler is now floating freely away from the program compiler, which means that I'm getting all the new GCC warnings that get added in with every release. While they may be locked down into a particular version that's tied to the actual hardware platform, but I'm able to sort of float independently of that and actually take this quite a good ways before I ever reach a blocking point. And the dynamic analysis, I guess there's a couple tools, Rational Purify and Valgrind are great for that. But again, in order to keep myself isolated and independent of others, I tend to leverage Valgrind heavily. So increasing the number of resources, well, once you've brought your environment onto your local machine, onto your local area, then the number of resources and test articles is effectively unlimited because you have one per developer. So that becomes no longer a blocking point. The other thing is that becomes important, and certainly for my development, is how do we bring people in? How do we get more people, more programs involved? So if I go back to my specific case, there's the amount of cumulative amount of time I get on the end platform that's fully integrated, or actually can even perform most of the functions that I use, amounts to almost nothing. But there are other programs that exist that may need parts of what I have, and so then I go off and I do not actually. And this is where I think the Linux philosophy comes in: is there's no program or use case or environment that somebody proposes that I come back and say, no, that is an invalid test configuration. So your result is meaningless. Instead, what can I do to actually support that environment, be it x86, 64, whatever? I'm going to support all of it because that's really the only way I'm able to get enough results back in order to get an idea that I have a quality product. So there's other things. So when we're looking for feedback, we're also running into problems. And how do we actually identify those problems and get results back? And so I took a look at the trend lines for embedded Linux queries and Green Hills queries on StackOverflow.com. I realized that the support available is probably great, but I know that this is, for me as a developer, this is the first place I'm always going to turn for everything because I pretty much get all my answers there. Maybe because I'm not very creative in the questions that I'm answering or asking, I guess. But so what we see is that embedded Linux has far more activity than Green Hills in this example. And obviously, if I extended that out to the Linux kernel in general, the numbers go up much farther because I'm doing a very specific tag there. And we can actually go farther about how are we using the community to not only get answers, but actually figure out what we're going to do in the future. And so there I took a look at So what is available on GitHub? If I just compare the number of repositories available, you get this astronomical number of Linux-related repositories versus VxWorks repositories. Are most of those usable? Probably not, but I think it gives you an idea of the products that are out there that then you can potentially leverage in your product, and then be able to actually make design decisions. Obviously, the cheapest, your best method of labor costs is not actually having to do the development in the first place. And I thought what was really interesting was the sheer number of contributors into the Linux kernel itself under the Linus Torvalds repository. So 3,422. That's this huge number of resources that are potentially available for any program to take advantage of. So where I'm really interested in going then is, how can we actually build something that kind of grows and goes on even beyond programs and throughout the wider community. And so most flight software isn't so flight specific, very little, except for the GNC is obviously a big exception to that. But what I would like to see is if we can actually move into creating our own stack. So if you look out into the Linux community, what you would see is that there's an automotive grade Linux community. There is a carrier grade Linux community. There's Yocto specializes in customized Linux distributions, and there's the secure Linux, the SE Linux community, which is the partnership with the NSA. There's all of these communities out there, all of which are sort of growing, and they're all connected underneath that Linux framework. And then so now we're actively engaging into the community out there instead of just taking the products back. And then what I would like to see is, what are the connections that we start making? Obviously there's a lot in common between the flight software community and the automotive grade community, for example. But what would be out there, what are those connections that we're not even aware of yet into, I don't know, bizarre fields like finance or something, because finance really used to be real-time Linux heavy. They now might be moving more towards high throughput. Are those changes that are going into the kernel, are they relevant back to us in the flight software community? So then you end up having this thing that one of the slogans I like to remember back to is Andy Hunt the Pragmatic Programmer. His comment was that software is like gardening, and we have a tendency in the flight software to think of software as a building that we design and then it's there and that's it. But if you think of it like gardening, it's something that we need to that's living, and you need to continue dealing with it at all times. Which is why, if I go back to just the fact of rolling in new kernels, rolling in new compilers, these things all drive changes into flight software, and they keep the software alive for a longer period of time. And the software really does need to be kept alive. And so then you ultimately get to the goal, I think, which is Linus's law, as noted by Eric Scott Raymond, which, given enough eyeballs, all bugs are shallow. And hopefully once we've significantly engaged the community, we can start achieving that. And so then I'm about to wrap up. So I think Linux is a viable platform for flight software. I would actually be curious if there are particular reasons why it is not viable, because I'm not really sure what those would be. You should always maximize the number of resources you have available in whatever fashion that is, because once you lock out a particular resource or a particular use case, well, then that's somebody who's going to fork or go their own direction on their flight software. So you need to figure out how to embrace those. And I believe it is possible that we could develop a full stack that then can exist independently of any individual mission and can sort of grow on independently of us all. And that's all I have.
Is this on?
Yes.
Well, this isn't so much a question as a comment. You were wondering why Linux wasn't really favorable for firmware on like a piece of flight hardware.
Right.
Okay. Well, for what I'm doing, the reason why there's a couple of reasons why we didn't like Linux as an operating system. One, it had a whole bunch of lines of code.
Yes, it
and
does.
there's actually another real-time operating system out there that
Right.
has fewer lines of code that looks like it's designed to fly stuff.
Mm-hmm.
Another reason that we didn't want to go with Linux was because in other projects out where I work, we noticed that Linux has so many forks that it becomes like this huge versioning nightmare to resolve things and stuff like that. So we actually wanted something that had more control over what they were doing. So we actually favored an open source project that had fewer forks, but also had a good development community. So I mean, that's what we were looking at. So there's actually real-time operating systems out there that support a wider variety of architectures than even Linux does, with more software maturity. So that's why we were looking at doing something else. I mean, I'm not criticizing Linux. It's a great platform, but I mean, from the research that I was doing, it looked like it had some real issues with real-time stuff. So that's
If you notice, I really wanted to focus on just the fact that there's community out there and an open source style of development rather than Linux specifically. That's so. Personally, I believe you should use whatever is the best tool for whatever your program is. What I don't think you should do is really write your software such that you block out the potential of using different operating systems. That's where I get bothered. But
okay.
Thank you. Other questions?
So I'm glad you're speaking today. A couple of comments and a few questions. Number one, could you share a little bit about the servicing mission that your organization is working on? I think the satellite servicing mission.
the robotic servicing mission.
Yes. And then also, could you share a little bit more about Yocto as well and the potential for building kernels for various processor architectures? And the last question is sort of a general question. We can envision that in the future there'll be a man on the moon again. In your imagination, what kind of processor architecture would the lander have, and what operating system would the vehicle have? That's the last question, so you can answer all three.
The robotic servicing mission. So what they're working on at NASA Goddard is a robotic arm that can autonomously grapple onto a satellite, and I guess it wasn't. I don't think they specifically have indicated to me what exactly they would be doing after they grapple, but they're mostly focusing at this time on the machine vision in order to identify the locations on this particular satellite that they're dealing with, and being able to lock onto that. So it's a very interesting project. That's in ground test. They don't have a flight manifest yet, but the interesting parts of that is definitely the autonomy of it. It's not man-controlled at all once they give it the location. Your second question was Yocto. So Yocto is the customizable Linux distribution. I guess I don't really have much to say about Yocto at this time. I guess gotta say I'm not an expert on that. So I apologize for that. The third question was man on the moon and processor, and something I'm surely unqualified to say anything about. But I guess I would be curious. My initial thought would be some variant of an ARM processor, I guess, and just because I think that seems to be a good path forward right now, and the operating system that would run on it.
The voice of Rob.
That's fascinating. I guess my thinking would be, I would be looking towards something that probably doesn't exist today.
So you guys are flying ARM, right? You are. You can.
Flying ARM?
You intend to fly an ARM processor, at least. That's what.
Oh, that might be for a program that I'm not involved in. Okay, so I do believe that Mike mentioned that,
yes.
And that might be for, I'm trying to remember which program that might have been. That might have been the Naval Research Laboratory or some program they're not discussing. That's all.
Any other questions?
Oh.
So this is a question you probably can't answer, but maybe it's the topic for your next year's talk, which is there a place for Android in space?
I believe there was the Android Nexus went into a CubeSat. So, and one of their ideas behind that was that maybe they could use Android I think one of NASA's ideas for that was they could use possibly Android as the basis for a future operating system.
So, as Linux is primarily like a desktop operating system, I'm a big supporter of Linux in general, but I think they, I find that they tend to value throughput a lot more than sort of reliability.
Right.
And those tend to be competing requirements. I was wondering if you could address that.
Did you say throughput versus reliability?
Throughput versus maybe dependability, I guess, of scheduling.
Okay. Yeah, I can certainly see that throughput is certainly a driver in the Linux community, primarily from it forms the basis of probably 50% of the servers out there. The reliability stance, that's where I guess I'm leaning towards the high availability Linux and carrier grade Linux communities. What their approach is to effectively use redundancy and probabilities in order to actually achieve the availability guidelines that they need. So, yeah, I think that's a concern. I think there are communities out there that are trying to address that.